Hello, Mrs. Merzak here. I have some 10.3 homework hints. So the first one is just another way to do the first few. So number one is like find a sub 6 when a sub 1 is 3 and r is 4. Again, your numbers may be different, but the concept should be the same. One way you could do it is using the formula. So you could plug in the 3 for a sub 1 and the 4 for r, and then our n that we're interested in is 6, and so 6 minus 1 is 5, type it in. Another way you could do it if you would like, since it's like pretty small numbers, you could start with 3, so type in 3, enter, and then you can times that by 4, and if you do just times 4, it does answer times 4. So 3 is the first number, and if you press enter, that's the second number. And since we have answer times 4 already set up, if we press enter again, it'll take this answer and times it by 4, and all you have to do is press enter. So here's the first one, second one, third one, fourth, fifth, sixth. And so yeah, that's another way to get it kind of by hand in the calculator if you have kind of a short one. Okay, the next ones I wanted to mention were like 5 and 12. The directions say type integer or simplified fraction, but it takes a decimal. It did for me for both of them. So say you have like this kind of thing and you get a long decimal, try entering the decimal and see what it says. If for some reason it doesn't take it, one way to turn a decimal into a fraction like on the calculator is going into the math button. And then the first thing is arrow frac. And if you do that, and the answer is able to turn into a fraction, like it's a rational number, then it'll do that for you. And so that's like another way in case it doesn't take it. Okay, so number 10 has like a sigma notation. So we can do these in our calculator. But one thing that we'll want to be aware of is the calculator doesn't have eyes. So when we begin, it'll, we usually use X's in the calculator because I is like its own letter. And so when we pull up sigma notation, maybe use X's. And then also, we're going to want to add an extra layer of parentheses to let the calculator know, hey, we want to sum up all of this whole thing. Like, this exponent is in the stuff that we want to sum. So have double parentheses in 10. So the last three I want to talk about are 17, 18, and 19. They're a little bit different. So this one at first glance is like, oh, you're adding 13. It must be arithmetic, and every single time you're adding 13. But you're not adding 13 to the previous number. You're adding it to the n number. And so let's start making like a little table. So when n is 1, when n is 2, and let's do another one just so we could see if there's like a consistent pattern going on. So to get a sub 1 when n is 1, we take n, which is 1 right now, and we add 13. So that gives us 14. To get the a sub 2, the second term, we'll take n, which is 2, and add 13. So that's 15. Now n is 3, so 3 plus 13 is 16. So the pattern is not adding 13 every time. It is adding something consistent, but it's adding 1. And so this one, we would choose arithmetic because it's either adding or subtracting a consistent number, and the number that it's adding or subtracting is a positive 1. It's adding 1 every time. Okay, so here's number 18. It's similar to number 17. It gives a thing, and you're like, oh, okay, there's like an exponent. That's kind of weird because it's not adding or subtracting or multiplying or dividing. But let's plug in and actually find like the first couple numbers of the sequence. So when n is 1, a sub 1, or the first term, is going to be negative 8 to the 1 power, which is just negative 8. When n is 2, we have negative 8 to the 2 power, so negative 8 times negative 8 is positive 64. And when n is 3, we have negative 8 to the 3rd power, so negative 8 times negative 8 times negative 8 is negative 512. So now that we have the first few terms, let's try to find the pattern. So to get from -8 to positive 64, and the same thing has to happen between positive 64 and negative 512. I think it's multiplying by a -8 every single time, because there was like one -8, here was two -8s, here was three -8s all multiplied together. So since it's multiplying, it's going to be a geometric one. That's multiplying and dividing. And the common ratio, or the thing that you're multiplying by every time, is -8. Okay, so the last one's number 19. Here's the pattern, so let's kind of see like what the first couple terms are. So the first term when n is 1 is going to be 1 squared plus 8. So 1 times 1 is 1, plus 8 is 9. And the second one is 2 squared plus 8. So 2 times 2 is 4, plus 8 is 12. And the last one is 3, and is 3. So 3 squared is 9, plus 8 is 17. So let's look for the pattern. So to get from 9 to 12, either we could add 3, but adding 3 to 12 won't get us to 17, so it's not add 3. Maybe it's like a geometric thing. So to get from 9 to 12, we multiply by, that's like a little tough. It's maybe some fraction or something. So we could take, to find what we need to multiply to get from here to here, we could do the reverse and divide them. So we could do 12 divided by 9, the second term divided by the first term. And that would maybe simplify to 4/3. So if we did 9 times 4/3, we'd get to 12. Let's try 12 times 4/3 and see if we can get to 17. It doesn't. It's not 17. Or another way you could think of it is the third term divided by the second term, 17/12, and see if it reduces to 4/3 again. But it doesn't. This would like have to be something other than 17. So this doesn't multiply by something consistent every time. It doesn't add or subtract by something consistent. It doesn't divide. And so this pattern would be like a neither. It's not adding or subtracting. It's not multiplying or dividing. And so it's something other than arithmetic or geometric. So yeah, there's the last one. Have a good weekend. I'll see you guys later. Bye.